All right, well, hey, welcome to this. I'm Dave. I've been working on geoprocessing analysis team for 16 years now. This was going to be my temporary home at one point, but it kind of grew on me, and here I am, years and years later. The whole geoprocessing framework, the whole building script tools thing, kind of started way back at 9.0. We've evolved, kind of several times through that, but even the tools that were created at kind of at the beginning could still, be functionally pieces that we can even use right now today. It's made it through Pro, and now who knows how long it'll go, but I don't see any end in sight for building script tools. Yeah. So originally this was going to be actually like a two-part kind of thing. There was going to be like a more intro-y kind of session. That's how I've normally done it. That's how we did it last year. Kind of had to switch things around because of some number games. So we're only kind of doing this half of the session this year. So the description there kind of suggests two parts, but this is the one part this year. For those of you just coming in, everything that I have today, that all the scripts, all my tools, not the data, but the slides as well, is on that link there. So you don't have to type anything down furiously or scribble things on paper. You can just look at it there kind of now or after the fact. The main four areas I'm going to cover today, we're just going to talk about validation, we're going to talk about kind of some core code organization strategies, some debugging, and then some more things like packaging. Those are kind of the four silos that I have, but they kind of bleed into one another. So, when I finish the little validation section, we're going to still talk about validation throughout the entire thing. All right. So when I think of a geoprocessing tool, there's really kind of three chunks of things that we kind of need to figure out. One is just creating the parameters. We're not going to talk too much about that today. There's the actual source code, right, what the tool actually does, and then there's the validation code. So the validation code is really that kind of interactive when you're working with the tool in the UI, right? You click somewhere, something else happens, right? Those kind of little responses, like calculating a default based off of another parameter, turning things on or off, indicating when certain criteria are problems or not. It can also be used to define the output. So when you're connecting tools in Model Builder, your tool can properly connect in with other things. The next tool actually knows what your tool is going to produce even before it does. Now, when we kind of look at it mechanically, there's really just three things that are key. These three things you're going to be responding to when the validation happens. So, we get code like this, but really it's mostly about responding to what the value of the parameters are. If it's like data, then we can describe that data and get more data properties. And then also whether that parameter has been altered or whether that parameter has been previously been validated. Now, with the altered, that's kind of like what the upper right example is. So I have one parameter where it's like a data source, and another parameter where it's some kind of numeric value that I'm calculating off of that. So what we don't want to do is have someone type in a value and then strip it out on them, right? So I check, in this one up here, there's first parameter is a value. We'll check if that other parameter has been altered or not, right? And if it hasn't, then we'll do that calculation and push the value in ourselves. Otherwise, we'll respect what they put in themselves. Now, there's two main validation routines. There's update parameters and there's update messages. Key is to kind of make sure you don't mix them up. If you put messages in update parameters, they get kind of dumped because there's an internal routine that happens in between. But if we do need messages, it's mostly about evaluating, this combination and this combination of values are, legal. We know the tool will fail later if we keep them going through, so let's validate it when the tool is running at the beginning. So we mainly use that. There's a set error message method that comes off of each parameter. Now, I'm going to dive into a demo in a minute, but there's a couple little things I just want to make sure throw in front of you. So when we're doing validation, you can get the value or you can get the value as text. If it's data, like a layer, you want to almost always use value as text, just because the value creates a layer, and you can actually see that little lag, especially in Pro when it's doing that. So use value as text, pretty much universally, value only in kind of special cases. And you can actually bypass it in another way too. Like if you have to describe data, just describe the parameter object. You don't have to do the parameter object dot value or even value as text. You just describe the parameter itself. And one other thing is when we have, validation code, well, back up. When you create a tool and you create parameters, there's like a list of properties you can set, right? Data type and filters and a bunch of different things. The parameter objects, if you ever look at it, that actually has a number of other things that we can set. So sometimes, things like setting a category, right? The collapse parameters, turning things on and off. You can even adjust the control in Pro. You can't do that through the UI, but if you do it in validation, you can enable for those things. All right. Okay, so the first demo I'm going to use, I'm pulling some data from this site called seanlahman.com. I don't know if anyone knows what that is exactly. It's actually baseball data. Now, baseball data isn't particularly spatial, but what we do have, is all these players have birthplaces, right? So I created this little tool, and well, let's just look at it. So actually, what you're looking at the data there, this is like a cluster hotspot analysis of baseball players in the early 1800s and where they were born. So I wrote this little tool that mines some of that data from seanlahman.com. So it's organized as CSV files. So I can pick, this has all the kind of like personal information, the player name, their birthplace, all that. And then this one is kind of a very large CSV of all their like statistical information over time, right? So every player, every year, right back to 1871. So the way I set it up, you could either pick a specific year or you could pick, kind of a range. So let's just do 1 year to start. Okay, now while that's running, let's just have a brief look at the code. Look at the source code. Is that large enough to read in the back? Yeah, okay. So when you have a script tool, to get the values from the front end of the tool, when a tool button, you hit OK, right? We access those values through get parameter or get parameters text. For Booleans or long values, I use get parameter because then I get it as the native type, right? Boolean or long, I don't have to convert it from a string. Now this particular tool, right, not that long, it's only 70 odd lines. Really all I'm doing is taking those CSV files, doing a little bit of work with pandas, right? Just merging those two sets together, doing a little bit of work to pull out the years I want. And then I kind of flip it over to some geoprocessing tools and I geocode it, and then I do a little hotspot. And that's that. I was wondering how long this would run today. There we go. So yeah, you can see this is one I ran earlier, right? It's pretty much as expected. This cluster of baseball players in the early 1800s is, of course, kind of Northeast United States. If you look at it more recently, right, it's kind of spread across the US, South America, Central America in particular, right? We got Japan, North or South Korea, right, and a few other places like that. Now, the thing about validation in this is I wanted to avoid kind of a situation like this, where, you can kind of interactively changing dates. So like maybe put 2000 to start and, something before that. Oops. right? I get an error for that, right? Because, I know that's invalid, right? I want to avoid that in my tool, so I create a little bit of validation to handle that case. So in Pro, you can actually look at the validation right inside the script tool. I didn't want that. All right, so when I created this tool, the parameters here, both of these are range filters. I don't tend to use range filters on longs a lot. When I use filters, it's mostly against like string parameters, but this case works too. So I set it, in the script tool properties to those dates, right? Now, I want to be able to adjust those dates based off of what I picked in my values. So if my first one has a value, I want to update it to the filter of the second one to that year plus 1 and going up again to the maximum year. If not, I'm just going back and reset it to what it would have been originally. Now, that wasn't actually my first instinct. I think that works best because we're kind of relying on properties of the parameter. But alternatively, we could have done something like this, where it's like, I'm actually going to explicitly check the values against each other, and instead of relying on kind of the standard GP messages, I'm just going to throw up my own, right? So as long as both of those parameters had values, the second value was less than the first value, then I know it's an error. So there's kind of two different ways of dealing with it. This is the way that I ended up going with in the end. Now, when we get to kind of managing code with script tools, and I'm going to talk about script tools and Python toolboxes. I should have asked this at the beginning. Is anyone, or who's using script tools or creating script tools now? How about Python toolboxes? Yeah. How about both? Yeah. Okay. Well, yeah, we're going to talk about both of them. They're really just kind of different ways of getting to the same goal. Whichever you prefer is whichever you should go with. But now, with a script tool, one kind of always present obstacle is that the validation code actually sits inside the toolbox. That's a little difficult in one respect because, right, it's kind of hard to manage that, right? If you're doing any code tracking, who knows what's happening in that binary TBX file, right? Or, if you want to share that code between different tools, right, you kind of got it stuck in a way that's hard to access. And it's definitely hard to kind of like develop with it like that. So you got your code, right? You go in there, you make some changes, you come back, and oh, I did it wrong, right? There's a lot of bouncing back and forth. So I'm going to show you a little bit of strategy for how I do to kind of pull it outside and kind of manage it better that way. Python toolboxes, we can do something similar. So Python toolbox on its own, the only thing we really need from it is the PYT file, right? So the way we recognize it, is that it has like a PYT file and it has toolbox class in it. Anything else in that file, any other code we want to have, we can have somewhere else and pull it in when we want it. On both of those cases, we use a little strategy. I use a little strategy called just import lib.reload. So I can, when I'm actively working on it, I can kind of have it constantly being refreshed so I can see it in a quicker and more deliberate way. Okay. All right, so this little tool, this kind of funny little tool, it was kind of, someone asked me for it a few years ago when it was part of like a larger user conference plenary presentation. So, it's kind of been sitting in my pocket for a few years, and every once in a while I kind of pull it out and tinker with it a little bit. So what it does is it takes like a classified raster like we see right here, and I can, this parameter is a feature set, so I can either, right, I can draw and interactively a feature. Right, and I could kind of clip and do the analysis there, or I could actually pick, you know, a feature class I have. Now you note actually there's an error here. It says, you can't read that, clip area outside raster boundary, which is, you know, false, right? You can tell that just by looking at it. That's because they made a boo-boo in the validation. So let's just have a little look at that. Right, I'm not trying to be shady. So, right, there's the right and the wrong way. So the way this is supposed to work, right, if each of those, the input raster and the feature set are both have values, I'm going to describe both of them to get the extend, and then I can get a polygon from that extend. And then I just want to use a geometry method to compare if they're disjointed or not. And of course, you know, when we were looking at it, they weren't disjointed, right? But so obviously this is wrong. So, you know, I could fix this, right? And that should be just fine. But, you know, I had to come in, you know, come out, you know, I can make a mistake, come in again, come out again, right? It's kind of this awkward experience. So what I've taken to doing is something more like this. So this is exactly the same tool, just a duplicate, except I did something different with the validation. So in a script tool, right, we have this thing called tool validator class, right? It's just kind of boilerplate stuff that you add to. Well, I carved it out. Now, there's actually more here than we need. This is really the only line I need. This is just here so that, you know, I can pull it up in one window, you know, in an IDE, make my change, reopen the tool, and it will, right, the change will be there. This is just temporary. So as soon as I'm like satisfied with the tool, I'm ready to like hand it off to someone else to use, you know, I would get rid of this, right? I don't want to forcibly reload things, but it's a good strategy while you're kind of interactively working on it. So in fact, well, yeah, line 9 I definitely need, right? Yeah, that line stays no matter what, because that's what's actually pulling it in, yes. Yeah. So, right, if I did then something like, where are we? Right, you know, it's just kind of, right, now I get the behavior that I expect. Now, the other one I wanted to show you, so this is, well, that's running. This is a Python toolbox. So, a colleague of mine, Linda Beal, some of you may know Linda, she created a series of tools a number of years ago in a toolbox file. And they're actually kind of cool, interesting tools, so I've kind of tinkered around with them a little bit. Sometimes I made kind of my own little Python toolbox with some of them. But let's just look at one of these here. So this tool, well, maybe I should just run it and then we can see what it does. Okay, so let me, the toolbox itself, all I have is this. All right, so the color's not coming in because it's a PYT file, but it's still Python code. All right, so in a PYT, really all you need is a toolbox class, right? You know, that file extension plus this toolbox class, you know, it'll be recognized as toolbox. So normally, like if you create like a default one, you just, you know, context menu, new Python toolbox, you'll get, you know, that plus a tool class kind of sketched out for you. Well, I've carved out all that stuff into separate files and I just import it back in, right? And again, I kind of use that strategy of using import lib, and then I can just, forcibly reload it. So every time kind of I reopen it and all this comes in, right? I don't have to do the kind of crazy back and forth stuff. So yeah, what this tool does is it's kind of like a historic dots pattern. So, back before computers and whatnot, some people use strategies like this to kind of like show contours. So we've kind of modeled it inside of a geoprocessing tool. So you can kind of see, it's like a dotted line, and the more dense areas, right, that's like steeper, and then actually you kind of wash out the effect of the flatter areas. We actually kind of strip out parts of the contour, right, to kind of give a more, I don't know, I kind of like how the 3D effect of that comes out. But what the tool does is almost secondary here, right? So go back here. So right, I'm just importing from one of my own files. So inside here, right, this is my main little worker function. Not actually that complicated, it's just 3 tools, right? That's it. Now, for the toolbox itself, like the structural part of it, right, we have a tool class, right? It's kind of a particular class with a well-known structure. Most of this is fairly similar to a script tool, of course, but in Python Toolbox, we define parameter objects instead of doing it through the wizard. Now, this one doesn't have any particularly interesting, maybe except for this. Right, I'm setting symbology based off of a file that sits relative to my PYT file. Now, script tools don't have this yet. I'm kind of angling to change that to 4. But in a Python toolbox, you can have there's an is license check. So I can say, hey, is the spatial analyst extension available? Because I'm using all these spatial analyst tools and I don't want to fail, later on, right? So you can set something like this, and in any case where it returns false, right, the tool can't be activated because it's not enabled for that extension. Now, for myself, inside execute, right, which is really what happens when you hit OK, I carve all that stuff out to my own little separate function, right? Execute's really just a place where I organize my parameters and then send them out. And then that's it. Now, just because we left this running. So you can see here, back to that little bit. That was the final output. It used mostly little NumPy and a couple of geoprocessing tools to create this output, and it's really just kind of summarizing up some attribution. So for instance, we can find like the biggest continuous area in that little spot. Okay. Now, partly for some of the things I talked about with the toolbox, debugging of Python-based tools has been a little bit difficult historically. Some of you may be aware of some of these kind of like, I don't want to say hacky, but kind of certain ways of getting out information while the validation is happening, right? So in some ways it was kind of like a black box, right? You change some parameters, and something happens. So these are some of the strategies I've historically used to kind of pull information out, right? And just mine the parameters and what the certain properties are and, put them into messages or into another parameter for the time being. So that was never the best. So a few releases back, this is a little year ago now, 2.1, we started introducing, more of a proper strategy for debugging, really anything Python-based inside ArcGIS Pro. So I'm going to use Visual Studio 2017. Actually just reinstalled it last week, so put that on, plus the Python tools, which was just another thing to click on. The only, I guess, caveat is it has to be a PY file. So like the last two things, right? I can't debug a PYT file directly, but I can debug the PY files that it uses. And same thing for a toolbox, right? I can't debug TBX because, well, that's a binary file, right? We can debug the Python files that it uses. So I guess the only trick is you got to make sure that the Python's initialized. So when you're using ArcGIS Pro, you just kind of activate that somehow. You can already run a Python-based tool, it'll be active, or you can just kind of like I do, just click on the Python window, and that will engage kind of a Python process. All right. All right, so if we go back to this tool again, now remember this one, right? I carved out the validation into a separate file. Now, I'm going to debug actually the validation code, which was always the more difficult thing to kind of figure out and debug. You could use the same strategy to debug the source code, Python toolboxes as well. But I'm going to do validation. Let's just make sure, yeah, that's the one I want. So to do this, yeah, I'll reload that. Let's put it back in its wrong position. So I can just go and attach this to Pro. So all the defaults will be fine, and then Pro here. Now when I'm doing this too, like there's a, the debugging is not the only thing I actually want to show you here. This kind of like reveals a few things that are maybe not as clear, or it kind of makes things more obvious. It's kind of my intention with this. All right, so it should be attached. Let's create, just throw in a bunch of breakpoints. Okay, so now if I did everything right, no. Try that one more time. Okay. All right, so we're in. Now the interesting thing here is, if you look at the tool, right, it's not there yet, right? It's kind of still starting up. Validation happens more often than most people, I think, realize. One of those is actually when the tool starts up, right? Validation gets called. So one thing to watch for, kind of a big, general no-no, is to have like errors on your dialog when you start up, right? You don't want to have illegal parameter combinations right at the bat. But also, right, in this case, there's nothing there. Everything should really be well. Like if we check our parameter values, right, that's none, that's none. Okay, so continue. All right, it opens up. So now, let me take that first breakpoint off. Let's start hitting that. Start hitting that a lot. Okay. So again, we can pick our classified raster. Let's pick, instead of a feature set, we'll just use this baseball area. Okay, then we're back in. So this joint, which is what I wanted to check, right? This joint of those two extents is false. Okay, so, right, that's what we expect, but this is if not false, so of course that's true. and we get something we don't want. So what we'd rather have is that. So if we come back, launch that tool again, should get what we want. Right, so now this joint is, well, still false, and right, the check fails, so we're good. Now, the one thing in here that is maybe a little, well, now you have access in the debugger to all the parameter information, right? So there's a lot of stuff there. So kind of keeping track of, like, even myself, like things like has been validated, never really quite have it on top of my tongue, like what it actually does. So being able to see it kind of interactively, check it in like a debugger like this has been really helpful to me. You know, not only do I see, like, you know, the kind of the things that change, like altered, false, or sorry, altered, yeah, the value and has been validated, right? There's, you see, you know, kind of everything else that's going on inside that parameter, right? So, you know, you can forcibly change things in here, right? You can kind of see the effect of what happens. I haven't talked too much about schema today, but that was that thing I said at the beginning where you can alter how the tool sees the output, right? You can kind of see how that is kind of organized, and you can adjust that as well. Okay. Now, one thing about like toolboxes, Python toolboxes, normal toolboxes, you know, in a way they're, you know, they're their own kind of transportable piece, right? You just give the toolbox and all the associated Python files or the PYT and whatever it has, and someone can just put it on their machine and kind of use those tools, right? That's good. The only trouble is necessarily, you know, you got to put them somewhere. You got to remember where they are, right? It's kind of like almost like a second-class citizen. So we have this approach where you can kind of organize your toolboxes as packages, as a module itself, and then it kind of becomes more like live. It gets treated as if it's just like another ArcGIS system toolbox, right? So it appears, you know, alongside data management and analysis and all those toolboxes. So I'm going to show this, kind of how we do this. So I think I can close this for now. Yeah. So on the second demo I had was that Python toolbox that had, right, had that historic dots tool in it, and had another tool in it as well. So I'm going to create a little module out of this. So the way you do this, right, so module in Python, just a folder and with an init file, right? You can have more than that, but it's very basic. That's kind of what it is, right? You may not see that, but that just has my name in it. It's nothing fancy. I'm using this merely as kind of like structural stuff to make this happen. So I'm going to take all the contents that I need. I'm just going to copy that and put it over here. Now, I'm going to open, I'm just getting into the Python command prompt so I can run a single command. So it's importing ArcPy. And then yeah, it's kind of hidden function, I guess. It's right, there's like, you haven't observed it already, there's like an arcpy.gp, because historically speaking, right, the arcpy is kind of just built off of ArcGIS scripting module, if you go back far back. So you can see in here, there's something called arcpy.gp. I'm going to check my notes or I'll spell this wrong. There it is. Create toolbox support files. Right, just like that, right? And I copy the path in, it's just going to run off and go and create a little structure for me, right? Some of the structure I need to make this happen. All right, so you can kind of see, or maybe not, they just added an Esri folder, a folder called Esri. All right, so what I'm going to do is I'm going to take all of those things again. So it created this structural stuff. Once you, not only can you kind of see the toolbox in this framework inside the application, you also can get it kind of for free in ArcGIS without having to kind of do your own import toolbox. So create a folder called toolboxes. And I'll just paste that content in. And then I can open Pro. Now this is like certainly not like the only way, like there's kind of other strategies you can use to like package tools. I'll talk about some of this more. But this is kind of like a handy little way of kind of this like making the toolbox like a first class citizen, right? Now, one thing I should elaborate on too, like when I did that, I just kind of just copied the folder. Oh, I didn't actually copy the folder, did I? Hold on. I'm just managing it as a folder, right? I could certainly like make this, like I could, like disutils or something like that and make more of a package out of it. Then I could have like a little installer with it. Sorry, I jumped the gun there. So I'm just going to take that folder, copy it, and put it. All right. Now I created my own environment, right? You can create your own environment in Pro. If you have admin access, you could put this right into the default environment and use it that way. If you don't, you got to create your own environment, and then you just kind of drop it in here. And then now I can open Pro. What's that? It reads that only at startup. It reads that only at startup. Yeah. So you can't, this is no like refresh kind of thing, but yeah, you do need to restart to see it. So at this point, really all the kind of access points you think of with geoprocessing tools should come alive with your tool. So if I look in the toolboxes kind of list view, right, this is my little toolbox. If I do things like a search for it, right, that'll show up as well. Yeah, right there. And then of course it's also there in ArcGIS as well. Right, so historic dots. Yeah, and there it is. Okay, so that's kind of one strategy, probably my favorite strategy for kind of distributing toolboxes. It kind of gives that kind of extra oomph because it just kind of goes in and then there it is, right? You don't need to continuously remember where that is, navigate to it, find things that kind of way. Now, anytime you do have, you make your own script tool, your Python toolbox, even other flavors, model builder, you can kind of go and do more with that. Just one note, actually, I'm not going to be able to do this part in complete justice, so there actually is another, the demo theater this afternoon that talks about this in a lot more detail, kind of creating geoprocessing services with Python script tools. Now, kind of backing up slightly from that, right? Anytime you run a geoprocessing tool, it goes into the history. Now, from the history, our tools, your tools, you can click on them and create a package out of them. Kind of as part of that same process, you can also click on it and make a service out of it as well. Basically, that part is just kind of ensure one, the tool runs, right? And that, everything, obviously, that the tool needed to run successfully is there already. So one little tip, if you have like a long-running tool, you may want to make that tool then asynchronous over synchronous. Now, when we're actually kind of creating that tool, a couple things that will help kind of in the preparation of the data. Now, some of these are good lessons anyways, like even if you won't make a service tool out of your script tool. Generally speaking, I try and avoid hard coding any data paths in my tool. I kind of have them I want them to be independent of that. I don't want anything kind of hiding in the background. I'm going to make the user put the parameter in there themselves. Right, so usually, discourage internal kind of data. Use things like get parameters text. If you do have hard-coded paths, there's two good ways and one not so good way. There's two good ways where you can either fix the whole thing right in there or do like a relative path thing like ospath.join. That allows, when we're packaging it up, to kind of find it better. If you're doing something more like, concatenating paths as like strings, we may not necessarily find the data as it is. So usually kind of avoid that one. And the other thing is if you can, or where you can, use the in-memory workspace. So actually at 2.3, we added, I don't know if you know this kind of history, there's been an in-memory workspace for a number of releases. There's actually kind of a souped up better one called memory now. Write your intermediate data to that location, right? Kind of saves, IO costs, to disk and reading it back. This goes into memory. If, it's small enough, right? That's kind of usually a better strategy. In my one tool, the geocoding data went into the in-memory workspace. And then, just a kind of a few last tips to kind of look for. I don't know if I can explain this in the appropriate detail. This is kind of more for that session this afternoon. But it's kind of describes how data is found, right? And this is kind of important for how and to avoid kind of like overusing certain data. All right, and that that's all I had. I went a little faster than I thought. So if you probably seen this thing already, feel free to complete the survey. Appreciate anything you have to offer. But otherwise, thank you. I'm done. But we do have some time, so if you, I don't know, if you have questions, we can take a few from the audience, and then after that kind of winds down, I'll just kind of invite people up to the front. Does anyone have any questions? All right, the hat. What's that? Sorry.
Can you attach to ArcMap like you did ArcGIS?
Oh, okay. The debugging thing, whether we can do that in ArcMap? No, that's a pro thing only right now. Yeah, sorry. Yeah. Yeah. Over here?
You had a demo where the user used an area of interest, was able to draw something. I haven't seen that in ArcMap 10.6 in the script tools. Is there a way to do that in ArcMap 10.6 or is it just ArcGIS Pro?
Okay, so that was about my tool that had like the interactive parameter.
Where the user draws a polygon for your raster tool.
Yeah, so that was just a feature set parameter. Yeah. And yeah, I think that was it. There wasn't anything extra really special about it, just the feature set parameter. And then when you have that, you have, yeah, go ahead.
Yeah, I just hadn't seen that capability in ArcMap 10.6 for the user to draw a graphic.
Okay. Yeah, there's something similar to that in desktop as well. It's a little bit, there's a couple more steps, I think, to make it work, but it's something similar is possible in ArcMap as well. Yeah, okay. Yeah, oh, way at the back. I don't think I got that. Sorry, what?
Yeah, can we use an INI file, like, and then use a big parser to read from the INI file?
Okay, using an INI file to...
Right. To basically get paths so that you don't need hard-coded paths in the scripts.
Oh, you mean, does our process do that, or could you use that? Like you want to use that in a tool? Would it pick that up? Yeah.
And we just have an INI file with no notification and read paths as key value pairs from that.
Oh, and I'm not sure if I have it all, but whether it can be packaged as well? And I have that right? Maybe you should come up after. We're just too far. Yeah. All right. Okay, I think at this point, if you have any more questions, including yourself, if you want to come up, just come on up and I'll be here for whatever it takes. Hey, thank you, Ken.